All right, so this is going to be some practice problems on using the expanded mole thing that we were looking at on the last little video. Except for now, we're going to actually follow some of these arrows from the reactant side to the product side and vice versa. So number 5, this is on your 11-2 practice problems. We're going to do number 5. I'm just going to kind of write through it, and you can take a look at it. And then when I'm done, I'll talk about it that way. So this is number 5. First thing we got to do is write the balanced equation. It's the decomposition of hydrogen peroxide into its two products, which, again, this is not given, so a lot of you probably just wrote down H2O because it says one of your products is H2O. But we all know that hydrogen peroxide fizzes, and it gives off a gas, and it gives off oxygen. Remember, oxygen is one of our diatomic elements. So then we have to balance this. We want to put an even number. We got 3 oxygens on this side. We got 2 on this side. So let's get this back to an even. So we now have 2 oxygens, and 2 is 4 hydrogens. Put a coefficient 2 on the front on our peroxide. We now have our balanced equation. Once it's balanced, we can then solve the problem on number 5, which is taking 0.77 grams of H2O and converting that into grams of H2O2. So this is a gram to gram problem, just like we did in the mole problems in chapter 10. So the only thing is now we got a conversion between water and our peroxide. So 0.77 grams H2O. First thing is we convert that into moles of H2O. So 18 grams of H2O, which we get from our periodic table, is 1 mole of H2O. We now can convert water into hydrogen peroxide with our balanced equation. So we have 2 moles of H2O from our balanced equation is equal to 2 moles of H2O2. And then we have to get grams of peroxide. So we know that 1 mole of H2O2 is going to be 18 plus another oxygen, so another 16. So we get 34. I think that's right. Grams H2O2. Cancel everything out that needs to be canceled out. Again, it's good practice. When you get done, we should have 2 sig figs in our answer, and it should be 1.4 grams H2O2. So that's number 5. Next one I want to do is number 9, and I'm just going to do the balanced equation for number 9. So let's do that one. So there's number 5. You can go back and look at that as many times as you need to. Number 9 is one that I hope you were working on it. It says you're going to see the decomposition of ozone, O3, into O2. That's the equation. Now we just got to balance it. And to balance that, you should have put a coefficient 3 there and a 2 there, and then you can solve the rest of number 9. I'm not going to do the rest of that one for you. If you have questions, again, email me with specific questions, and I will get right back to you with those. That was number 9, just real quick. Let's do number 10, because again, it's a decomposition of good old glucose, another one that we see quite a bit. This one here, it says we have liters of carbon dioxide at standard temperature and pressure. How many grams of glucose will that give me? So I'm just going to start this off to save a little bit of time. It says we have 1.82 liters of carbon dioxide. Okay, so we know we're going to have to convert that. So we got to take liters of carbon dioxide and turn that into moles of carbon dioxide. And we know that the standard for this is 22.4 liters for every 1 mole. Then, from our balanced equation, which is given to us on problem number 10, it says, what is the comparison between moles of carbon dioxide and moles of glucose? And in this case, we have 2 moles of carbon dioxide for every 1 mole of C6H12O6, good old glucose. Okay, and then our last equation is to get this to grams of good old glucose. So 1 mole of C6H12O6 is 180 grams of glucose. And again, very important little conversion, this last one. We've done it a number of times. You've did it in other problems up to this point. And it's one that shows up on tests a lot of times. Cancel again, everything out. And yeah, take your time and do this. It's going to save you getting little nitpicky points knocked off of tests and quizzes in the future if you go through and set your problem up. I look at the beginning, I have 3 sig figs. So I know when I get all done with this, my answer needs to have 3 sig figs. The only units I have left are going to be grams of glucose. And all I have to do is plug this into my calculator and see what I get. And in this case, you come up with 7.31 grams of glucose. That's number 10. Okay. So again, we converted it from a volume to a mass. So if you look at your scale, we went from a volume to the moles, then to the mass, sorry. So volume to mole to mass. That's how we did it. And in fact, we did it the opposite way because we actually started with a product, carbon dioxide. So we actually started right here, went product to mole to, what did we actually start with and decompose? Okay. Then I wanted to do one quick one on the back page. And this is going to be number 19. And this one here is, we're going to burn propane. So that means it's a combustion reaction. They give us a balanced equation for it. Propane plus oxygen gives us water and carbon dioxide. And in this one here, number, I said 19, right? So let's just start off with what we're given. 2.8 liters of oxygen. Now, this is a problem that if you read through it and you look at your table, this is asking for a volume to a volume. So that means we can go right across the from each other on that. So in this case, if I look at my balanced equation, it tells me that if I have 3 liters of carbon dioxide, I'll get 5 liters of oxygen. I'll get 1 liter of propane. And in this case, we're going to go from oxygen to carbon dioxide. So my conversion, right from my balanced equation at number 19, I'm going to look at the difference here. I got 5 liters of oxygen. Okay. And that is going to give me 3 liters of carbon dioxide. That's for my balanced equation. Liters cancel out. So then I just got to go 2.8 times 3 divided by 5. Now, one of the things that does happen is when you cancel things out, sometimes we get going so fast, we'll go 2.8 times 3, and we'll forget to divide by that coefficient on the bottom. Don't forget, we had to go multiply by 3, divide by 5, or divide by 5, multiply 3, whatever you need to do. You should come out with 1.68 liters of CO2. But that's not the right answer because there's only 2 sig figs. So you should get 1.7 liters of CO2. Again, those of you that have worked through these problems and have already sent these to me, and I told you that you're doing a great job, double check your sig figs. That's usually the biggest thing that you get a little note on when you get back an email. It's like, hey, watch your sig figs. Watch your showing your work. So if you're doing these, the rest of the problems, 1 through 25 on those practice problems, they're great. They're a great help. And what they'll lead to is tomorrow I will be going through all of this 11.2.1, this apply. So if you have that all done, we're going to do that together as one whole worksheet. And we'll get that out to you tomorrow. And then we'll be ready to go from there. All right?